AI and quantum computing.
Thank you, everyone, for taking the time on 10 a.m. on the second day of Sigma to actually have some patience and try and understand what the hell quantum computing and quantum mechanics are. You're all very, very brave. To start, I think we begin with a couple of intros. Taylor?
Thank you. Hello. So I'm also still trying to learn about quantum mechanics. So we're all in this together. My name is Taylor. I've been more involved in the VR interactive 3D AI side for the past 10 years or so. So that's really the part of this panel that I'm here to support. Been in Malta for about 3 years now, and yeah, happy to be here.
Thank you so much. Mr. Xuereb?
I'm André. I'm a professor of quantum physics at the University of Malta, so at least I can cover the quantum side of things. I know very little about AI. I use ChatGPT a lot, which is fun. And yeah, apart from that, I run a quantum cybersecurity startup, so we can talk about cybersecurity as well. And I think one of the discussions we were having back then was kind of, what will quantum ever do to me? Or for me, rather. So maybe that's something we can talk about.
That's hopefully something we'll get to answer eventually. As a bit of personal background, I am not a quantum guy, I'm not an AI guy, I'm a blockchain and cybersecurity guy, so I sort of come at this from a bit of an interesting angle. But before we dive in, show of hands, how many people feel as though they have a basic understanding of quantum mechanics? Basic, right?
He was one of my students. So
okay, cool. That's unfair. Come on. All right, fair. So I think we should begin with Schrodinger's cat. I think that's a really good place to start, right? So, and we'll leave it to the quantum physics professor to explain to you exactly what that is.
I should have had more coffees for this. Okay.
2 minutes, dude.
2 minutes. Okay, I've got a clock there. Okay, so let's do this. We'll get to Schrodinger's cat very soon. One of the first thing I tell my students when starting the quantum mechanics course is nobody understands quantum mechanics, so it's fine if you don't understand it. Ultimately, what do we mean by that? A lot of the things I will mention, discuss, talk about are things which our brains are simply not equipped to comprehend. So yeah, how do we learn how the universe works? When we're kids, and I've got too many kids for my sense, when we're kids, we just keep throwing things on the floor, dropping them. That teaches us something called Newton's laws of motion. The universe pulls things down to the floor because of laws of gravity, blah, blah, blah. It turns out that quantum mechanics violates pretty much every single law, every single piece of intuition that we have. So, for example, in quantum mechanics, if I kick a football in that direction, it literally goes in pretty much every single direction at the same time. If I kick a football towards a wall with 2 doors on it, then the football could actually go to both doors at the same time. By the way, this could be really cool for iGaming. We should explore this.
Give it a shot. But let's start with the cat.
And then the cat. So what was the idea behind the cat? So ultimately, we now know that we're very, very confident that this is how the universe works. You can get small things being in 2 places at the same time, switches being on and off at the same time. That gives us quantum computers. It gives us many things. But why is it only small things that work like this? Can't I just get a cat and have it be dead and alive at the same time, in exactly the same way? And Schrödinger conceived this idea just to show how absurd the whole thing of quantum mechanics is. So it is an example meant to illustrate how absurd quantum mechanics is. And the idea is that if I do things in the right way, my cat in a box will be both dead and alive, literally both at the same time, until I open the box and observe him. Now, we don't know why this doesn't work, so we've tried it, but it doesn't work. But it does, the main idea, the theory, is actually the main idea and the theory we use behind all of quantum computing, all of quantum mechanics anyway. So the ideas work, but we have no idea why they don't work on cats or people.
Fair. Taylor, do you want to supplement that?
I mean, one thing I heard that stuck with me was the idea of if you take a coin and you have a binary computer where you have a 1 and a 0 on either side, and it can either exist as a 1 or a 0. Whereas with a quantum computer, it's essentially like a coin spinning on its side. So it exists in both positions at once, and when you observe it, it collapses to one of the sides. So it can kind of exist in this superposition state that quantum is the only thing that enables that, whereas binary computer, it's either on or off. So it kind of allows these things, when they're observed, I'm probably oversimplifying it, to sort of collapse into the correct state.
If I may, and one of the nice consequences of that is if you have a computer that's based on this idea of a qubit, a quantum bit, being on and off at the same time, then what you can have is a system which operates on all the possible different inputs at the same time. So it's like it's the best possible version of a parallel computer that you can think of, because it will take all the possible inputs, operate on all of them at the same time, and spit out the answer at one go. I'm oversimplifying by quite a bit, but this is kind of the superpower that quantum mechanics gives you when applied to quantum computing.
So let's maybe take a bit of a stab at like a real-world example of superposition, right? So your wife's at home and she's getting ready, and you've agreed to go to a dinner party at 7:30, and you're going to pick her up at 7 o'clock. At 6:30, you have no idea if she's going to be late or if she's going to be on time. So technically, that's basically superposition, right? It's not a 0 or a 1. That's the
At the risk of my wife killing me, I know she's not going to be ready on time. I think that's. But there is some truth. There is some truth to that.
Oversimplifying it, right? Oversimplifying it.
But there is some truth to that. Yeah, it's a bit different.
Agreed.
But
So. We know that there are limitations in quantum computing, right? Like, we know there's a couple of quantum computers around the world. We know they can run for between 3.5 and 5 minutes before they completely fizzle out. But we know sort of AI is in a completely different stage, right? In the sort of progression curves. So how do we see these two parts crossing over? Shoot.
If I may.
Just keep the mic close.
From my perspective, I said nobody understands quantum mechanics, and I wasn't being silly there. So part of the reason why quantum computers are kind of growing and becoming more powerful more slowly than we'd like to is that we don't understand the basis of the tech fully, and I think we never will. But we also know that to control that tech is extremely difficult, and I think we've reached a point where being able to use very, very large AI models, and not large language models, but other kinds of AI models and machine learning, and basically feeding them all of our experiments, all of what we've done so far since the 1920s, and telling them, okay, this is how the universe works, this is what I'd like to achieve, build me a system that does this. And there are kind of baby steps in this direction, and we are seeing what I would call kind of new physics experiments, which are completely AI designed. So I would say kind of one way in which they will converge is AI as a designer for new or frontier technologies. I'm seeing frontier tech here on the seats.
Shout out to Ikigai.
Shout out to Ikigai, yeah. So AI for designing frontier tech, that's one side. The other side, which I'm much less of an expert of, is using quantum to speed up processing for AI models. I'm much less of an expert there, but I know there's a lot of work being undertaken there. That's my perspective as a quantum guy there.
What do you think, Taylor? Do you think we'll sort of use AI to bridge the lack of understanding that we currently have in quantum to be able to figure those problems out for us? Or do you think the convergence will be somewhat different?
I would hope so. I mean, I'm not knowledgeable enough on quantum to have a good answer for that, but I think the thing that's really interesting to me about quantum in my work is basically quantum simulation. So being able to actually simulate how things work at a quantum scale, which is how the world fundamentally works, to our knowledge. So basically being able to actually create an experience in a virtual world, a virtual experience, that simulates reality down to the quantum scale, which is really exciting and interesting and starts getting into that sort of matrix style concept. So for me, that's what's really exciting about quantum, is the ability to actually create these quantum simulations.
Yeah, I mean, I'm an educator, I teach, and one of the things which I'd love to see maybe we should collaborate on this. But one of the things I'd really love to see is kind of the idea of if we created an immersive environment which does kind of bring to the large scale the laws of quantum mechanics, would our brains change? Would our brains be able to get an intuition for how these things work? Because as I said, they work completely differently to how we expect them to work. So it's one of my long-standing questions, and I'd love to explore that at some point.
Yeah, because if you could go down to a quantum scale and experience things at a quantum scale, I mean, it's probably going to be wrong, whatever we simulate, right? It'll be so random that it will be right and wrong at the same time, I guess. But ultimately, for me, that's where it's super powerful, is being able to change the perspective to go down into those levels that we know exist at an atomic scale or a quantum scale, but we just can't access it in our human size. So being able to actually go down and experience that.
Absolutely. Just for those of you who like these sorts of things, maybe have you ever come across a slower speed of light? So MIT built a game that does exactly this, but for the theory of relativity. So you walk through the game at walking pace, and you start seeing all the weird things that Einstein predicted, and it gives you a strong sense of, okay, this is how the world, how the universe works. Which is an interesting kind of analogy. You should check it out.
It reminds me of a time I tried VR ayahuasca. That's what that sounds like to me. I have no idea why.
It's very trippy.
That's literally what just came to mind.
It's very trippy, though. It's very trippy.
Okay, so look, it's commonly, I think, agreed upon that quantum has particular applications in terms of encryption, and specifically in breaking it. Why? The simple explanation is, if you try and brute force some kind of password, the process is very simple. You try one, it doesn't work. You try two, it doesn't work. You try three, and you keep stacking, and then you stack another number, and another number, and another number, until eventually you break through. The idea of quantum is, okay, I'm gonna now attend something with a possible a character limit of 7 different characters, and I'm gonna shoot out every possibility at once, and we're gonna see which one returns something positive. So that's a relatively simple use case. The same thing could be applied to the traveling salesman problem, right? So find me the fastest route. At the moment, the way we do it is very inefficient, and there's much better ways to do it. But these are sort of two, let's call them low-hanging fruit in terms of use cases, right? What do you see will be the next tangible use case that quantum can really bring into this world?
Okay, so yeah, I mean, you mentioned a couple of the big ones. There are a few other known, almost low-hanging fruits. So there's a known way to speed up searches. So if I have, Google-sized database that I need to search quickly, quantum will, in principle, be able to speed that up. I mean, there are some caveats. We haven't yet, designed a system to do that, but there are some ways of doing that. Another approach, which is, you mentioned quantum simulation in one sense. There's a different kind of quantum simulation which I'm involved with, and that is using quantum to simulate, for example, how materials work. And the idea there is, we know, for example, it should be possible to build what are called high-temperature superconductors, but basically wires that don't heat up when you send current through them, which could be very, very beneficial for mass transit, for energy grids, and so on and so forth. Those kind of materials we don't yet know how to build, and there's a very good reason for thinking if we had a good quantum computer, we'd be able to kind of design those mechanisms.
That's super
those
cool.
materials.
So what you're saying, just so I understand, right? What you're saying is we could use quantum to effectively create new kind of composite materials
Absolutely.
that could have a whole bunch of purposes we never even thought about.
And until a couple of weeks ago, before the AI guys got there first, we would also say you could use it to design new drugs and new biomolecules. But I think AI has now solved that problem, as it happens. So yeah, they stole that from us. But yeah, I mean, from my perspective, breaking...
What are your thoughts on that, Taylor? I'm seeing you just like, yeah, okay. He agrees. That's a rarity, right?
But yeah, breaking cryptography, I think, is the one which is not the sexiest, but definitely the one with the furthest reaching consequences. If someone had access to a quantum computer it's not just your passwords. What they would be able to do, and this is not hyperbole now, what they would be able to do is sit anywhere on the internet, sniff that traffic, and within a couple of minutes be able to decrypt all that traffic that's going through that part of the internet. So they could target, the government data centers, they could target your data centers or some high net worth individual, and basically be able to break through all of their communication systems. They could spoof them, they could do all sorts of things. So anyone with access to a quantum computer could really spell trouble to all of our kind of crypto system at the moment.
So we know that a couple of countries out there and a couple of governments have their own quantum computers. And like we said, it's a 3.5 to 5 minute sort of burn time until this thing gets so hot. It just constantly.
Oh, yeah, sorry.
3.5 minutes, right? 3.5 to 5 minutes. So how far away are we in terms of minutes of operation to be able to consider quantum espionage as a thing?
Okay, so two answers to that question. One is more speculative than the other. Based on how things are moving forward, I mean, if you went on the IBM quantum site 3 years ago and you compare that to what they have today, it's exponentially better. And if you I know it's dangerous to extrapolate, but if you extrapolate a bit, 5 years seems to be a sweet spot. So let's say 2030-ish, it seems to be a sweet spot for when we expect companies like IBM to have something which is a genuinely useful general purpose quantum computer.
That's quick.
Behind the scenes, we have absolutely no idea. I mean, the top researchers of the field have a habit of just disappearing and ending up working for the intelligence agencies. So we really have no idea what's going on behind the scenes. The scarier part, if I may, the scarier part of this is this. When I was talking about earlier that someone can steal, intercept traffic on the internet and break it in a couple of minutes, that sounds scary. What's scarier is that, and we know this is happening, people can and do steal encrypted traffic going over the internet today, store it, because storing something for 5 years is cheap. It costs nothing. Store it for 5 years and then sell it to an unfriendly government, sell it to the highest bidder, basically. And at that point, the highest bidder has a library of data from the government of Malta that will just take them a few weeks to break into. And therefore, knowing that quantum computers are coming in the next, say, 5 years is not sufficient for us to say, let's just sit down and do nothing for the next 5 years, because our data now, last year, is already being stolen.
Fair.
And this is scary for me.
Fair, but I think if your sort of hunch is right, then in 5 years we'll have that Pentium 1, right? But in terms of AI, it's already a threat now, right?
Yes.
Some crazy things are going on in the world, right? So, Taylor, what do you think is the biggest threat, I think, that sort of AI poses in its current form?
I mean, there's of course all the doomsday scenario, narratives that are out there. I think those do hold true. I think the physical manifestation into robotics is more unlikely, although getting more likely every day. I do think really it's malicious actors using it maliciously, and it's really, I think it was Sean who said this last year. It's about the person behind it. It's the people who are dangerous. It's not the AI itself. I mean, the AI eventually could get out of control, and we don't really understand exactly how they work a lot, especially these larger models we're spending 10 billion eventually. I know Microsoft and others have plans for $100 billion data centers to train these models. So once we get to that scale, I mean, we're not really going to understand how these things fundamentally work, and they might develop motives of their own. But I do think that there is a lot of good work from companies like Anthropic. I mean, they're really leading the charge in terms of safety, in terms of really bringing awareness to these things. All of their models go through rigorous testing for if they have nuclear threats, if they could have malicious intent for shutting down power grids, they go through all these interesting tests, actually, which I learned about recently, all this testing that's required now at a government level in UK, US, globally now. I think other countries that are less regulated, that have a lot of capital, that's where a big risk is. I won't mention any names, but I think that's a big risk, because once it gets out and it's deployed onto the internet, it's kind of open territory.
Okay, and to
I'm just going to add, I think deep fakes are probably the biggest threat at the moment, in my opinion, from what I've seen.
Definitely the biggest threat today, that's for sure. So to end things on a more sort of positive note, what do you guys think is going to be, and give me a 10-second answer, what do you guys think is the most positive thing that AI would bring in the next 5 years?
Hopefully post-scarcity.
Post-scarcity, and in terms of quantum?
AI for quantum, oh no, positive thing, quantum. I mean, it's going to be able to develop these new materials, new things, which are going to save lots of carbon, lots of money. And there are companies democratizing quantum computing for everyone. So hopefully the whole world will benefit as well.
Super. Gentlemen, thank you so much for your time. Audience, thank you so much. Have a wonderful day.